Imagine using a translator before computers even existed. In 1929, that idea sounded almost impossible. There was no Google Translate, no smartphone, and no artificial intelligence. There was not even a modern computer capable of processing human language. But in Salerno, Italy, one man was already thinking about this problem. His name was Federico Pucci. He was a linguist, translator, and inventor who understood several languages. Pucci knew how difficult communication could become when two people spoke different languages. He wanted to find a way across that barrier. And he believed translation could be transformed into a system that, in theory, could be followed mechanically step by step. In December 1929, Pucci presented his study of what he called a mechanical translator. The goal was extraordinary: help Europeans communicate without knowing each other's languages. At first, Pucci focused on related Romance languages, including Italian and French. His idea was not a modern computer. It was a rule-based method built around symbols, keys, and linguistic relationships. The process was designed to transform one language into another by following organized rules. Today, that sounds surprisingly familiar. But in 1929, the technology needed to make it practical barely existed. There were no modern computers to process language automatically. The machines of the era simply could not do what today's technology can. Still, Pucci kept developing the concept instead of abandoning it. In 1930, his work was displayed at a national exhibition in Bolzano, Italy. There, his mechanical translator concept received a silver medal. Then, in 1931, Pucci published his method in a book in Salerno. That book preserved his method and real translation examples. But then, Pucci's name slowly began to disappear from the story. Then the story takes a strange turn. Pucci's idea did not disappear after 1931. His work continued appearing in exhibitions, even as the world moved toward modern technology. By the mid-1930s, Pucci was still presenting his mechanical translator to the public. In 1935, his translator appeared at the Paris Trade Fair, where his method received another silver medal. That changes the story. Pucci was not simply an inventor who vanished after one experiment. For years, he returned to one problem. How could people communicate without learning every foreign language? His answer was simple: create a system that could bridge different languages. That system relied on international keys and ideograms, giving different languages a common structure. It was an early rule-based approach. Language was treated less like magic and more like a process. But there was a limitation. Pucci's method depended on human-made rules, not a machine that understood language. Every linguistic relationship had to be defined. The system could only work within those rules. Still, Pucci believed the rules could be expanded. His vision reached beyond one experiment. He imagined Europeans communicating while knowing only their native language, without a traditional translator. Those examples mattered because they gave later researchers something more valuable than a theory, something to test. But history became complicated. Pucci's work remained outside the famous story of machine translation. Other inventors soon explored mechanical and computational approaches to the same language problem. By the 1940s and 1950s, attention was shifting toward electronic computers, while Pucci's approach looked outdated. The strange part is that his original question had not disappeared. Technology had simply changed the answer. Decades later, those forgotten pages would give researchers one question: could Pucci's method actually work? But there was a problem. Pucci had described his idea, but could he actually make it work? He wanted Europeans to communicate without learning each other's languages. For the 1930s, that was ambitious. In 1930, his work reached a larger audience. His translator was exhibited in Bolzano. The invention even received a silver medal. But what exactly had visitors seen? Pucci's machine was more than a strange device. Behind it was a complete system for handling language. Words could be organized, matched, and converted through carefully designed vocabulary. Yet Pucci believed his system could cross one enormous barrier: completely different languages. And later, he left behind something extremely important: He published examples of his method. One example used a passage from Dante, translating it from Italian into French. Another took a passage from Voltaire's Zadig and translated it into Italian. These examples changed the story. Pucci had left more than an ambitious theory. He had left something researchers could actually examine and test. But then the mystery became deeper. Historians began searching for the machine itself. And that created a simple question. Where was the complete working machine? Yet Pucci did not abandon his idea. He continued developing it for decades. He imagined electrical systems, portable interpreters, and communication across distance. His vision was moving toward a future technology had not yet reached. Nearly a century later, researchers returned to those forgotten pages with modern technology. And finally, they faced the question Pucci never could. Could his method actually work? Nearly a century later, researchers returned to Pucci's forgotten idea. But now, they had something he never had: modern technology. They began with the pages he left behind, examining his diagrams and translation examples. By then, electronic computers were changing what machines could do. Computers could process enormous amounts of information, making mechanical translation seem possible. But the fundamental problem remained. How could one language be converted into another? Researchers began turning linguistic rules into instructions that machines could process. But now, electronic machines could handle those rules instead of mechanical components. For the first time, language could enter a machine as data and emerge in another form. The computer could calculate rules quickly, but speed was not the real challenge. The bigger question was whether calculating language meant understanding it. Pucci's old problem suddenly looked modern. The technology had changed, but the question remained. Researchers began looking back at his work, asking whether the system could be reconstructed. They translated his diagrams into a structured model that could finally be tested. Words became rules, rules became relationships, and those relationships could be processed by a computer. Now came the critical test. Could Pucci's method produce the translation he promised? Researchers compared the reconstructed output with examples Pucci had published decades earlier. Two worlds were meeting on the same problem: a 1930s inventor and modern language technology. Nearly a century later, the mystery became testable. But could Pucci's rules really translate language? Pucci's method had survived on paper. But one question still remained. Could those old rules actually translate language? Researchers tested the system against examples Pucci had published decades earlier. The results were revealing. The system could follow rules, but that did not mean it understood language. That difference would become one of the biggest problems in machine translation. Pucci's method depended on carefully defined relationships between words and languages. But real language was rarely that simple. Meaning could change with the sentence around it. A single phrase could carry completely different meanings depending on context and intention. That was something mechanical rules struggled to capture. And this exposed the real limitation of Pucci's vision. Organizing language was one thing, understanding it was another. Still, his basic idea was surprisingly familiar. Give a machine rules, vocabulary, and a way to transform one language into another. That same ambition continued through decades of computer research. Machines were no longer built from gears and charts. They could process enormous amounts of information in seconds. But more computing power did not automatically create understanding. Machine translation became a long struggle between rules, data, context, and meaning. And near the beginning of that story was Pucci, working with ideas that seemed almost impossible for his time. His machine never became the technology that changed the world. But the question behind it refused to disappear. How could a machine help people communicate across languages? That question would eventually become one of the biggest challenges in computer science. The final answer was more complicated than simple success or failure. Researchers found that Pucci's system was built around carefully designed rules for handling different languages. Each word had to fit into a structure connecting one language with another. That made the system limited, but it also made his idea surprisingly clear for its time. Pucci wanted translation to become something a machine could follow, rather than something that depended entirely on a human translator. And that basic idea would remain important to language technology for decades after his work was forgotten. Modern translation systems are far more powerful, but they still face a familiar challenge. How can a machine connect meaning across completely different languages without understanding the world as a human does? Pucci could not solve that problem with the technology available during his lifetime. But he had recognized the challenge remarkably early, when mechanical systems were still in their infancy. His machine eventually disappeared from the spotlight, but the question behind the machine refused to disappear with it. And that may be the most fascinating part of Pucci's story. History often remembers the inventions that succeeded, while the ideas that arrived too early quietly disappear from public memory. Pucci's translator was not the future itself, but it pointed toward a problem that future technology would continue trying to solve. Nearly a century later, researchers could finally examine his forgotten idea using tools that Pucci could never have imagined. Words became rules, rules became relationships, and those relationships could finally be processed by a computer. Now came the question that had waited for almost a century. Could Pucci's method actually translate language? His machine vanished, but the dream behind it survived. And the question Pucci asked so long ago still has no simple answer. But testing Pucci's idea revealed something even more interesting. His rules could organize language, but they could not capture everything that language meant. A word could change meaning depending on its context, intention, and the sentence around it. That was the part machines struggled to reproduce: human understanding. Yet Pucci had still reached an idea that belonged far beyond his own era. The future did arrive, but not in the form Pucci imagined. The machines changed completely, but the dream of crossing language barriers remained surprisingly familiar. And near the beginning of that journey was a forgotten inventor named Pucci. His machine did not change the world, but calling it a failure would miss the bigger story. Because his question survived long after the machine disappeared. Decades later, computers would ask that same question on a completely different scale. Language became data, and translation became something machines could process at speeds Pucci could never have imagined. But even then, one problem remained. Processing words was easier than understanding meaning. A machine could process words, but understanding their meaning was far more difficult. And that makes Pucci's old question feel surprisingly modern, even after almost a century has passed. Perhaps history is full of ideas waiting for the right technology and the right moment. So the real mystery may not be what Pucci built. It may be what his forgotten idea helped begin, and how many other forgotten ideas are still waiting to be discovered. The machine vanished, the question remained, and technology kept chasing the answer. Almost a century later, Pucci's forgotten experiment reminds us that the future does not always begin with success. Sometimes, it begins with one strange idea that everyone else forgets.